तो हेलो गाइस, कैसे हो आप सभी लोग। स्वागत है आप सबका अपनी यूट्यूब चैनल डिवोशन ऑफ नॉलेज में। मुझे पता है काफ़ी सालों बाद वीडियो डाल रहा हूँ, जैसे कि आप लोग देख सकते हो। काफ़ी टाइम के बाद हमारा लास्ट वीडियो 2 साल पहले अपलोड हुआ था। और तब हम 11th स्टैंडर्ड में थे। अभी हम कॉलेज में आ गए, कॉलेज भी आधा ख़त्म हो गया है, तो वीडियो डाल नहीं पाए, पर अभी सोचा एक वीडियो अपलोड कर देते। तो आज हम एक नए वीडियो के साथ आ चुके हैं आपके साथ, और आज हम एक कोड फोर्सेस का क्वेश्चन समझने वाले हैं। कोड फोर्सेस का एक क्वेश्चन समझने वाले हैं, जिसका नाम है फाइनल बॉस। ये अभी रिसेंट जो ड्यू फॉर गई है उसका एफ प्रॉब्लम है। रिसेंट ड्यू फॉर गई है उसका ये एफ प्रॉब्लम है। तो आज हम इसको समझने वाले हैं। सो लेट्स फर्स्ट अंडरस्टैंड द क्वेश्चन। एफ प्रॉब्लम, द क्वेश्चन स्टेट्स दैट you are facing the final boss in your favorite game. The boss enemy has H health. So the health of the enemy boss is H, and we are having N attacks. The ith attacks deals with the AI damage, means we will be given an array in which each element will be having a value, and that will be the value of our attack. Means the damage that we will deal with the boss having health H. Okay. So in each turn, we can use all the attacks which are not currently on cooldown. Not currently on cooldown. Please mark this statement. We will understand it after 2 to 3 minutes when we will understand the examples given below. मतलब जो भी कूल डाउन में होंगे उनको हम सबको एक साथ यूज कर सकते हैं, बाकी हमें वेट करना पड़ेगा उनके कूल डाउन होने का. So if all attacks are on cooldown, you do nothing for the turn and skip to the next turn. Initially, all attacks are not on cooldown. How many turns will you take to beat the boss? The boss is beaten when its health is 0 or less. मतलब हमें उसकी हेल्थ 0 करनी है या लेस देन 0, तभी हम बॉस को बीट कर पाएंगे. 0 और लेस देन 0 करनी है, तभी हम आंसर पे पहुंच पाएंगे. यहाँ पे कंस्ट्रेंट भी है, h और n का कंस्ट्रेंट है 2 into 10⁵, सेम 10⁵, और सम हमें बोला है कि 10⁵ पे एक्सीड नहीं करें. ओके, ये सब चीजें तो चलती रहेगी. अभी एग्जांपल के साथ समझते हैं. दिस इज द एग्जांपल. जो 3 दिया है, दैट इज द health of the boss, and 2 means the array which has, means the first array which is given is 2 1. This is the damages that we can apply, and the next line is the cooldown that each value will have to face after its application. Let's understand in detail. Suppose here the health is 3, so initially we can apply all. Initially, as per the statement, we can apply the whole damage. Suppose इनिशियली तो हमें बोला है कि इनिशियल टर्न पे हम पूरा डैमेज दे सकते हैं, तो इनिशियल टर्न पे हम 2 + 1 3 दे देंगे. तो यहाँ पे बॉस की हेल्थ 3 - 3 इक्वल टू 0 हो जाएगी. देन our answer will be only 1 second, only 1 turn, not second, 1 turn. But here next time, here in next example, the health is 5 and the array we are given is same 2 1 2 1. So initially we will give 2 + 1 equal to 3 damage. Initially we will give 2 + 1 equal to 3 damage. Okay, 5 - 3 equal to 2. Now the 2 here we are given cool time s2. Here we are given cool time s2. We are given cool time s2. भाई कहाँ चला गया कर्सर. हाँ, ये रहा भाई. इनिशियली कलर पे और रखते हैं वरना ये घूम जाएगा भाई फिर. Cool time is 2. So if we are applying it on turn number 1, then we can only apply this damage after the given value, means 1 + 2 equal to 3. मतलब हमने यहाँ इस टाइम इंस्टेंट पे अप्लाई किया है, तो इसके +2 के बाद हम इसको अप्लाई करेंगे. ये क्वेश्चन में दिया है. हियर you can use this attack in turn x + ci. ओके, तो हमने इनिशियली 3 का डैमेज दे दिया, हमारे पास बचा है 2 का डैमेज। अभी हमने ये टर्न 1 पे किया, we have done this on turn 1. So on second turn we can't use this value because it has a waiting time, means after 2 turns we can, so we can only use it on turn number 3. So on turn number 2 we will use this one because it has only gap of 1, so we can use it on 1 2 3, means after this turn, one after the one turn of the initial turn, means 1 plus 1 2, we can use it after the one turn of turn 2, which is turn 3, we can use this one damage on every turn. So we will give this one damage, it will have value 1. Now we are having two options. Now we are on turn number 3, we are on turn number 3. So on turn number 3 we can use this one also, we can use this one also. So by using any of the operation, suppose let's give damage of 2, which will give -1 health, the boss is defeated. Or if we apply -1, it will have 0, so we will also have the boss defeated. So total turns required is 3. I hope you all have understood the question. Now let me tell you one thing. This question can be solved by a normal approach also, means by just going through the for loop once, and if that value is not 0, we will keep on adding that, means brute force, in simple language, brute force approach. But here when I saw the editorial after solving the question, the author has apologized here because they were creating a problem, but the intended solution was not binary search. We are going to solve this question by the approach of binary search. We will see further after 2 to 3 minutes, but their intended solution was not of binary search. But the constraint that they have designed, the normal approach overflowed the data, as you have seen. Account of overflow with big cooldown, but they forgot the overflow can also happen on attacks. Means they have told us that the normal approach led to brute force, and many of my friends and many of the people who gave the contest have their problem solved in the contest, but after that the problem was hacked. Means the authors are also not knowing that such thing will happen in the constraints that they have designed. So here normal brute force can't be applied. So what are the other options that we can apply? See, let's go into intuition. If I tell you one thing, that if I gave you number of turns, say if I gave you turns as suppose 10 turns, and we are considering this example. So if I gave you 10 turns, can you defeat the boss? Can you defeat the boss of having health equal to 50? Can you defeat the boss if I gave you the number of turns as 10? If yes, then we will also try by giving some less number of turns, suppose 9. If also 9, then we will go to 8. If yes 8, we will also go to 7. And if 7 is not enough, to 7 turns is not enough to beat the boss, then 8 will be our final answer. Means see, I am telling you that let us take some random value. Let's try to solve that after that. If we are given that random value, can we defeat the boss? If yes, then we will try to have some optimum value, because we are said that we are supposed to take minimum number of turns, as it is stated here, minimum number of turns. So we'll have to we will have to get the optimal value. Okay, so if we suppose if x satisfy our value, then there are chances that x minus 1 turns can also satisfy the answer. X minus 1 turns can also satisfy the answer. X minus 2, we don't know, just we are taking an normal case in which this condition holds true. On the other hand, if we are given x, okay, x, if x is not able to defeat the boss, then we will take x plus 1. If that is also not able, we will take x plus 2. Means, are you understanding that we are assuming some random value, and based on that random value, we are trying that if it is able to defeat the boss, then we will decrease it and check it that is it optimal or not. And if it's not able to defeat the boss, we will increase the value gradually. So can you understand that this approach is somewhat of like binary search? Yes or no? Is this, does this approach seems like binary search, that suppose one end is 0 and one end is suppose 10 raised to 12 or 10 raised to 13? and we are having some mid value, and we will try this turn. If this is able, then we will go mid minus 1, this one. If this also divide this one, and suppose this does not satisfy, suppose this value does not satisfy, we will come here, not satisfied here, and gradually we will see. So do you guys think that this question is kind of binary search? Yes or no? Do you guys agree? Okay, yes or no? Okay, so now what will be our approach to solve it by binary search? What will be our approach? Okay, okay. Approach will be our binary search. See, you see the constraint. We are having only two options. The constraint is 10 raised to 5. Constraints are 10 raised to 5. See, so either we can solve it in O of n or O of n log n. Only two options are there. O of n square never work, because it will be 10 raised to 10, which is greater than 10 raised to 8. So this won't work. So the only chance or only approach we can use currently is n log n, which is binary search. Okay, we will see how. If I'm given suppose turns as t, okay, and I am having a cool time of suppose say a, let's say b, okay, we are having cool time of b. So suppose let b equal to 5, then 1, 2, 3, 4, 5. And as we say in the question, as we saw in the question, that on first turn, everyone's damage is considered, and on turn 1, no one is in cooldown state. So we will take everyone's damage and decrease it from the health of the boss. So while calculating, we won't consider the turn 1, because initially we will take the sum of the whole damage array and we will subtract it from the health of the boss. So we won't be considering the turn 1. So total there are turn 5, but as we are not considering the turn 1, so the value of t will be 4, okay, and b is 5. So you are given 4 turns, and cooldown value is 5. Can you apply? No, because after applying one turn, the next turn that I will be having, on which the damage will be applicable, will be 6, and here we are given 5. So this won't work. This won't work. Let's take another example. Let a turn equal to 8 and b equal to 4. So as I saw on turn 1, we are giving the whole damage. So we will consider t equal to 7. Okay, and here is 4. So can you apply it? Can you apply it? Yes, we will be able to apply it once, because after turn 1 is completed, we will be able to apply it on the 1 plus 4 is equal to 5. And 5 lies in turn 1, 2, 3, 4, 5, 6, 7, 8. First turn is done, and we will be able to apply it on the turn number 5. So yes, so we will be able to apply it by once, yes. So can you say that the number of times I can apply damage is equal to turns minus 1, because on first turn we have denoted everyone's value upon the cooldown time. So it will, if the element is array, then b of 5. This is where at cooldown time, this is the number of times I can apply damage, and the total damage that I have applied will be star a of I. Because if I am able to apply damage 2 times, for example, 2 times, and the damage that I can give is 5, so total damage that you will be able to give to the boss is 10. Are you understanding how the formula came? This is the main logic. If you are able to understand this one, the question is solved. Question is solved. This is the main thing that you have to think. The first one was that intuition, that we will be solve this question by binary search, and the other thing that you have to make this is just this formula. If you are able to understand this formula, boom, the question is done. This was the main step. If you are able to understand this one, question is solved. Question is solved. Okay, very easy. And also, we will have one edge case here. Not one edge case, but we will add it to reduce the computations. So initially, you are given array A and array B. Okay, A contains damage, B contains cooldown, So initial damage, as I told you, on turn 1, we will apply complete damage to the given array. So we will take sum of all this whole array, sum of this whole array, and if the initial damage is greater than or equal to health of the boss, then we will have only 1 second. So then we will do nothing. We will just see out 1 and tell. Simple. अगर हमने मतलब पहली ट्राई में हमने बॉस को मार दिया तो फिर आगे कुछ देखने की जरूरत ही नहीं है ना. बाइनरी से कुछ जरूरत नहीं है. अगर हमने पहली ट्राई में ही बॉस को मार दिया, then it is just see out of 1. I hope you guys understanding what I am trying to explain. These are our question, and we will apply a simple binary search. The question initially seemed to me very difficult because I was not able to understand question. This cooldown thing was not able to enter my mind. I was not able to understand this cooldown thing properly. But after just dry running it for 1 or 2 times, I just solved the question. So let's code it. Anyone? Any confusion? Let's solve it. Okay, so let's have a template here. Yes. So we will have health of the boss and the size of the array. We will take 2 arrays. We are just inputting these 2 arrays, putting the same code, and yeah, array B also taken as input. And yes, we will take int initial damage. Means at turn 0, we will have damage of all the array, the whole array. Oh, we are writing it in wrong for loop. Yes, initial damages. Now, as I explained you the base condition that if initial damage is greater than the health of the boss, if initial damage is greater than or equal to health of the boss, we'll just simply see out 1 return. Let's pack into the parenthesis or else it will be error. Okay, so now that edge case is taken care of, now we will apply the logic of binary search. Okay, no worries. So we will have to maintain 2 pointers, start and end. So we will take it int left equal to 0, right equal to 1 e12. You can also take 13, but there is no need to take 13. The question will be taken care of by just 1 to 10 to the power 12. Okay, and we'll also maintain a variable of answer. Okay. As you all know, the base condition of a binary search is that left should be either less than or equal to right pointer. Okay. We'll have int mid equal to r plus l minus r by 2. There's some mistake. Yeah, r plus simple, yeah, r plus l by 2, simple. Okay, done. Now we have got the middle value, and this is the middle value that we got are number of turns. That random value I told initially that by taking some random value into consideration, we will see that are these turns enough or not to beat the boss. So we'll see that what amount of damage we can receive by applying this number of turns. So we will iterate through the loop. So we will plus what? As I tell you, mid minus 1 by cooldown time into the damage that we have got. This is the formula that we derived. Okay, this is the formula that we derived. Okay, so it will give the sum of the damages that we can receive by applying that number of turns. Okay, recording is continued. Okay, now if the received damage, if the damage that we received by applying mid number of turns is greater than or equal to health of the boss, if it is greater than equal to health of the boss, then our answer will be equal to mid, that our condition is satisfied, that we have defeated the boss. But we will try to find optimal value. So we will update r equal to mid minus 1. Okay, r equal to mid minus 1. Okay, and if not, else, see, we will not be storing this mid value into answer because we are not able to defeat the boss. The damage received is either is not neither greater than or nor equal to the health of the boss. So here we will just update L equal to mid plus 1. Okay, and just we will the answer variable. Yeah, and the one thing is also remaining. See, as I told you that initial we have taken the damage of the whole array initially, and turn one we took the damage of everyone. So we have to minus it from the value of the health because we are not considering the turn one. Therefore, we are decreasing the value of mid by one, and we will do nothing. Just yeah. So test case we have to also take, and we will do nothing. Just output the value of answer into it. So this is our code, and let's try to run it. Here is the value on running the code. Some it is not running properly. F9 are the values 1, 3, 15, 25, 1, 1, 3, 15, 25. Yes, code is running properly without any errors. Let us submit the code. This one is the F problem. Let's submit it. Press the page. Yeah, it's accepted. It's accepted. As you can see, this is the code. The only key points that one has to keep in mind was to just derive this formula. This formula was the key step, and even before this key step, the only thing that you have to know this the approach, which is binary search. This was the main thing. Approach is which is binary search. And also, let's talk about time complexity. It will be capital O and log n. It's simple because here we are applying a binary search, and for every value, for every log n value, we are iterating a loop for 0 to n. So simple. The complexity will be of n log n. So here we concluded our problem, and I hope you guys would have enjoyed because I have uploaded the video after almost 2.5 years or 3 years. Yeah, because the recent video on my channel is of the 19th June and today is the 30th June. So after almost 3 years, I made a comeback on my YouTube channel by uploading this video, and I hope you guys liked it. And if you liked it, please enjoy and also try this code once. You please go through this problem once. It is a, as I explained you, it's a not much tough problem, but the only key points that you have to keep in mind is that you have to identify the approach. That approach is to be binary search, and the formula that we derived, that mid minus 1 upon bi into ai, that the damage that how much damage that you will be able to receive by applying mid number of turns. So that's it for today's video, and please give this try question a try, final boss, and hopefully we will also meet in some near future with another problem solution. in this easy manner that I've explained you. And till then, if any doubts, comment section is for you guys. So please feel free to comment anything. And so we are keeping up to this much for today's video. Have a nice day and keep learning, keep enjoying. Thank you.